All right, let's talk about the vibrant and sometimes kind of frustrating world of color. We're going to dive into the chemistry behind the fabrics we wear every single day.
You know that feeling, right? You buy this awesome, brightly colored shirt, you wash it maybe once or twice, and boom, it looks like you've owned it for 5 years. Well, that fading, that's not just bad luck, it's chemistry. And a lot of the time, the culprit is something called a direct dye.
So what even is a direct dye? Well, the name kind of gives it away. It's a type of color that you can apply directly to fibers like cotton, and all you really need is water. Now, they're anionic, which is just a fancy way of saying they carry a negative charge, and they just happen to love attaching to what are called cellulosic fibers. You know, stuff from plants like cotton, linen, and rayon. Sounds super easy, doesn't it? Well, that simplicity is exactly why they are everywhere.
So why are these dyes so common? Well, it really all boils down to just how simple and efficient they are.
I mean, if you look at the benefits, you can totally see why they're perfect for mass production. They dissolve in water, which is, the cheapest solvent on the planet. They naturally want to stick to cotton. They don't cost a lot to make, and the whole process is just incredibly straightforward. For a manufacturer, this is a huge win. It's a fast, cheap, and easy way to get color onto a ton of fabric.
Okay, but how does that color actually get out of the water and lock onto the fabric? It's not magic. It's actually a pretty cool molecular journey.
It all happens in four main stages. First, the dye molecules start moving toward the fiber, helped along by the heat and the sloshing of the water. Second, they get attracted to the surface, and they form this thin layer, kind of like a crowd gathering outside a concert venue. Third, diffusion kicks in. The molecules start moving from that crowded surface into the less crowded inside of the fiber. And finally, and this is the most important part, bonding. A hydrogen bond forms between the dye and the fiber. It's this bond that holds the color in place, at least for a little while. And this right here, this graph, it shows you the whole process in action. It's basically a recipe for color. You start with water, you add some soda ash, you turn up the heat. Then you toss in the dye, the fabric, and a wetting agent, which really just helps the water soak in better. You crank the heat again, add some salt to help push the dye into the fiber, and finally bring the whole thing to a boil. Every single step is carefully controlled to make sure that bonding process happens just right. But, like we hinted at, that simple process and that kind of weak hydrogen bond, well, they come with a major catch, and it is the exact reason your favorite t-shirt doesn't stay vibrant forever.
So here's the trade-off in a nutshell. You get all these incredible benefits. It's cheap, it's easy, it dissolves in water, and it's perfect for cotton. But all of that is balanced against one massive downside. The same water solubility that makes it so easy to apply also makes it incredibly easy to wash right back out.
The technical term for this is wash fastness, and as our source material puts it with a bit of an understatement, for direct dyes, it's not so good. In fact, it can be pretty bad. That weak hydrogen bond we were talking about, it's easily broken by water and detergent in your washing machine, and once it breaks, the dye molecules are free to escape the fiber and just wash right down the drain.
So is that it? Are we just doomed to a world of cheap but quickly fading clothes? Of course not. This is where the chemists get really clever and come to the rescue.
So if the first bond is just too weak, the solution is to add a second step after the dyeing is already done. It's called an after treatment. And these are chemical processes designed specifically to trap those dye molecules and stop them from making a run for it in the wash.
One absolutely brilliant strategy is to just make the dye molecule bigger after it's already inside the fiber. Using some pretty complex chemical processes, they basically link the dye molecules together. This makes a much larger compound that's now physically too big to squeeze back out through the pores of the fabric. It is literally like building a ship in a bottle.
Another method uses something we all learned in high school physics: opposites attract. Remember how the dye is anionic or negatively charged? Well, chemists came up with cationic fixing agents, which are positively charged. So when you apply this stuff, the positive agent acts like a magnet, latching right onto the negative dye. Together, they form this big, stable, neutral complex that is way less soluble in water and stays right where it's supposed to.
And the cleverness doesn't stop there. Other techniques involve using metal salts like copper or chromium to form a really strong complex with the dye, or even applying a whole different type of dye on top that sticks to the first dye instead of the fabric, creating this protective layer. Pretty cool stuff.
So what all this really builds to is a colorful compromise. It becomes pretty clear that in the world of direct dyes, there's no single perfect solution for everything.
To manage all this, dyers actually classify direct dyes into different groups. You've got your Class A dyes, which are self-leveling, they're easy, they just spread out evenly on their own. Then there's Class B dyes, which are a bit trickier and you need to add salt carefully to get an even color. And finally, Class C dyes are the most sensitive of all. You have to control both the salt and the temperature perfectly. It just goes to show you that picking a dye isn't just about the color. It's about balancing how it behaves, how much it costs, and the result you're trying to get.
So what have we learned here? Well, direct dyes are the simple, affordable workhorse for coloring things like our cotton clothes. Their biggest flaw by far is that they can fade really easily because of those weak chemical bonds. But chemists have a whole bag of tricks, these clever aftertreatments to lock that color in. At the end of the day, dyeing fabric is this constant balancing act between cost, simplicity, and how long you want that color to actually last.
So the next time you pull a slightly faded t-shirt out of the laundry, maybe you won't just see it as a flaw. Maybe instead you'll see a story of hydrogen bonds breaking, of molecules escaping their fibrous little home, and a testament to the elegant, everyday chemistry that colors our entire world. Thanks for tuning in.